Hello everyone, welcome to the course of Ultrasonic Testing Technology. The main content of this course is a classification of industrial ultrasonic testing methods. Through the study of this lesson, I hope to achieve the following teaching objectives. Master ultrasonic testing methods classified according to testing principles. Master ultrasonic testing methods classified according to the waveform used. Master ultrasonic testing methods classified according to contact modes. Master ultrasonic testing methods classified according to the number of probes used. Let's learn together. According to the different detection principles, ultrasonic detection methods can be divided into pulse reflection method, penetration method, and resonance method. The so-called pulse reflection method refers to the ultrasonic detection method that determines the defective information in the workpiece according to the position and strength of the reflected echo signal on the floor dictator's oscillograph screen after the pulsed ultrasonic wave emitted by the ultrasonic probe propagates into the workpiece to be inspected. When the ultrasonic wave encounters a heterogeneous interface, reflection, transmission, and refraction will occur. The heterogeneous interface here is the interface of two different media, such as the defect interface or the workpiece bottom surface. Furthermore, pulse reflection mode can be divided into defect echo method, bottom wave method, and multiple bottom wave method. Among them, the defect echo method refers to the method of determining the position and the size of defects according to the defect reflection signals returned from the workpiece. The bottom wave method is a method to determine the defect size according to the amplitude change to reflect the signal from the bottom of the workpiece. The multiple bottom wave method is a method to judge the internal defects of its workpiece according to the number and amplitude of the reflected waves on the bottom surface of the oscillograph screen. When the pointer scans, it detects the thin plate workpiece. Among the above three methods, the defect echo method is the most sensitive and widely used. Next, the defect echo method is explained in combination with legend. As shown in the figure, T represents the initial wave, B represents the bottom reflection wave, and F represents the defect reflection wave. From figure A, we can see that the ultrasonic wave is emitted from the probe and propagates into the workpiece. When there is no defect below the probe, the pulse wave signal on the oscillograph screen of the instrument includes the starting wave T on the left side and the bottom reflected wave B on the right side. Figure B shows that when the probe moves to the position where there is a small defect, part of the ultrasonic beam is reflected by the defect, and the other part of the ultrasonic beam continues to propagate to the bottom surface of the workpiece before reflection. Therefore, a defect wave between the start wave T and the bottom wave B appears on the instrument's oscillograph screen. Figure C shows that when the probe moves over the defect with the reflection surface larger than the ultrasonic radiation range, all the ultrasonic sound beams entering the workpiece will be reflected by the defect, and no sound beam will reach the bottom surface of the workpiece. Therefore, only the initial wave T and the defect wave F appear on the oscillograph screen of the instrument. Let's learn the penetration method. It is an ultrasonic detection method that uses the energy change information after the ultrasonic wave penetrates the workpiece to judge the defect information in the workpiece. The penetration method requires two probes to work together, one to transmit ultrasonic waves and the other to receive transmitted ultrasonic waves. When there is no defect in the workpiece, the receiving probe will obtain a strong transmitted acoustic signal. When there is a small defect inside the workpiece, The receiving probe will obtain a weak transmitted acoustic signal because the defect reflects part of the acoustic beam. When there is a large defect in the workpiece, which reflects the ultrasonic beam emitted by all transmitting probes, the receiving probe will not be able to receive the transmitted acoustic wave signal. At this time, there is no transmitted acoustic wave signal on the oscilloscope screen. Finally, let's know about the resonance method. It means that when the frequency of the ultrasonic wave entering the workpiece is adjustable, the change of frequency will lead to the change of the wavelength. When the thickness of the workpiece is just an integral multiple of the half wavelength of the emitted ultrasonic wave, resonance will be caused. When there are defects in the workpiece or the thickness of the workpiece changes, the resonance frequency will change, so the internal defects of the workpiece and the thickness of the workpiece can be inferred. However, this method cannot accurately locate and quantify the defect in the workpiece if it is generally used for thickness measurement of the workpiece. Second, according to the use of waveform classification, they can be divided into longitudinal wave method, shear wave method, and surface wave method. Longitudinal wave method, it is the ultrasonic testing method that uses longitudinal wave acoustic beam to complete the floor deflection of workpieces. It can also be divided into vertical incidence method and small angle incidence method. The normal incident method refers to the method of making the ultrasonic sound beam enter the test workpiece perpendicular to the workpiece surface for ultrasonic testing. After the ultrasonic wave enters the workpiece perpendicularly, it will be reflected when it encounters a defect or the bottom surface of the workpiece. After being received by the probe, the reflected acoustic wave will be converted into an electrical signal, forming a defect echo or the bottom echo on the wave display screen or the floor detector. This method is usually used for longitudinal wave straight probe floor detection. The small angle incidence method means that the ultrasonic beam is incident on the detection surface of a certain incident angle. According to the refractional principle of waves, when the incident angle is between 0 degrees and the first critical angle, the refracted longitudinal waves and refracted transverse waves will be generated in the test workpiece at the same time. The method of floor detected among using the refracted longitudinal waves is called small angle incidence method, also known as the oblique incidence method of longitudinal waves. The oblique incidence method can solve the shortcomings of the direct incidence method. The reason is that in the oblique incidence method, the main sound beam of the probe reforms a certain angle with the probe axis, and the areas that cannot be detected by the direct incidence method can be detected. S-wave method. It is a method that the longitudinal wave is obliquely incident on the workpiece surface through inclined wedge, water, and other media, and the incident angle is between the first critical angle and the second critical angle, so that the pure S-wave is generated in the workpiece for floor detection. This method is mostly used to detect internal defects of welds and pipes, or as an auxiliary means of the P-wave method to detect defects that are not easy to be found by the P-wave method. Surface wave method. When the incidental angle is greater than or equal to the second critical angle, the ultrasonic wave no longer enters the workpiece, but forms a surface wave propagating along the workpiece surface. The method of surface or floor detection is called surface wave method. This method is mainly used to detect surface and near-surface defects of workpiece. According to the contact mode of the probe, they can be divided into direct contact method and liquid immersion method. Direct contact method. It refers to an ultrasonic testing method in which only a thin layer of coupling agent is coated between the probe and the workpiece during the testing, which can be regarded as direct contact. This method is easy to operate and master. Small transmission or attenuation and high detection sensitivity. It is the most widely used method in actual detection. However, as the probe moves directly on the workpiece surface of the scanning, the flatness of the inspected surface is highly required. Liquid immersion method. It means that the probe and the workpiece are filled with a certain thickness of liquid medium coupling agent during the detection, and the ultrasonic wave first passes through the liquid medium and then enters the workpiece. This method is called liquid immersion method. In engineering practice, water or oil is often used as the coupling agent of liquid medium. When water is used as the coupling medium, it is called a water immersion method. This method belongs to non-contact ultrasonic flow detection. Because the probe does not directly contact the workpiece surface, it will not cause wear of the probe surface during the defect scanning. It can be used for flow detection of a workpiece with relatively rough surface. In addition, compared with the direct contact method, this method has the advantages of stable coupling, good repeatability of defective result, and easy to realize automatic flow detection. However, in this method, the ultrasonic wave needs to pass through the section of the coupling medium before entering the workpiece to be inspected, and the interface reflection occurs at the interface between the coupling medium and the workpiece, which will cause large energy loss and reduce the detect sensitivity. Therefore, in most cases, it is used in combination with focusing probe that can converge the acoustic beam and improve the energy concentration. According to the number of probes used, they can be divided into single probe method, double probe method, and multi-probe method. Single probe method, it refers to a detection method that uses one probe to simultaneously transmit and receive ultrasonic waves. This method is the easiest to operate and has a high defect detection rate. It is suitable for detecting to volume defects and area defects paramedical to the acoustic beam. However, defects in other orientations are difficult to detect due to low ultrasonic reflectivity. At this time, the detection direction must be increased or supplemented by other detection methods. Dual probe method. It refers that two probes work at the same time in a detection. One is only responsible for transmitting ultrasonic waves, and the other is only responsible for receiving ultrasonic waves. It is mainly used to detect defects that are difficult to be found by single probe method. According to the placement of the two probes on the workpiece, the scanning movement mode can be divided into parallel tap, cross tap, serial tap, and so on. Multiple probe method. It refers to the method of using more than two probes to combine together in pairs for flow detection, which is often seen in multi-channel and automatic flow detection system. The main purpose is to improve flow detection efficiency. Okay, that's all for the class. See you next time.